So in this last lesson of homework packet 1.3, we're going to continue with looking at simplifying radicals, but we're going to look at it in the context of adding, subtracting, and multiplying radicals together, and then simplifying them. So let's take a look at our first example here. I've got the square root of 12 plus the square root of 27. So what we're concerning ourselves with is how to simplify when we're adding and subtracting radicals. In this case, I'm adding radicals. Now here's the rule that we need to follow when we're adding and subtracting radicals. In order to add or subtract radicals, they must have the same index and the same radicand. What's the index? What's the radicand? If you look at the image over here, we have it illustrated what the index and what the radicand is. The index is what type of root it is. Is it a square root? Is it a third root? Is it a fourth root? Is it a fifth root? And so on and so forth. So the index specifies what type of radical it is. In our case, they are both square roots, so we're good. What's the radicand? The radicand is the piece underneath the radical. If I look at what I have a 12 underneath one radical and a 27 underneath the other radical. I do not have the same radicand. I have the same index in my example, but I do not have the same radicand. So I've got some work I need to do. Here's how I'm going to do this. I am going to simplify each radical as much as possible to see if I end up with the same radicand. Now, realistically, not very often will you have two radicals where you're able to combine them, because very rarely will they be able to simplify to have the same radical underneath them. However, we've set them up specifically so that as you simplify, you'll see that in most cases you'll be able to add together. So taking a look at this, what I'm going to do is I'm going to simplify each one. Remember from the previous lesson that if I want to simplify a radical, it means to get as much out from under it as possible. So how do I do that? Let me take a look at my 12 and see how I can split it up. 12 could split up into 4 times 3. The 4 could split up into 2 times 2. Since I have a pairing of 2's under the radical, a 2 can come out. So I end up with 2 times the square root of, and I've got this 3 left under there still. So another way to think about it is 12 splits up into 4 times 3. What's the square root of 4? The square root of 4 is 2, so that's why the 2 came out, but I still have this 3 left under. Because 3 you can't take the square root of and have it stay a whole number or an integer. Let's take a look at the 27. How can we break that up? I think I can break it up into 9 and 3, and then the 9 can break up into 3 and 3. Well, I do see that I have another pairing and then a lone 3 up here. All right. So the pair of 3's means that a 3 can come out of this radical. So 3 times the square root of, I've got a 3 left over, so I have a 3 underneath that radical still. And I'm adding these two together. So now that I've simplified each radical, here's what you're going to notice. We already have the same index, but take a look at the radicand. Both radicands after simplification are now 3. I am now set up to be able to add these two together. Think about it as adding like terms. I have 2 root 3's right here and another 3 root 3's right here. So how many total root 3's do I have? 2 plus 3 is 5. I have 5 square roots of 3. And that would be this simplified. 5 square roots of 3. So again, the concept is simplify each radical to see if they have a common radicand so that you can then add them together. So in this next example, you'll notice that I have 3 separate terms that we're adding and subtracting together. The first two, finding the sum between, and then subtracting that last term. The concept is the same though. They all have to have the same index, which they do because they're all square roots, but they also have to both or all have the same radicand. In that case, we don't. We do not have the same radicand. So we need to take these one piece at a time. Let's take the 18. And we need to reduce this down to 9 times 2, and then 3 times 3. I think that's how we can break 18 down. And I notice I have a pair of 3's. What does that mean? It means a 3 can come out of the radical. If I already have a 3 out here, it becomes 3 times 3. And then I have the square root of, it's the 2 that was left over. So 3 times 3 times the square root of 2, that's 9 root 2. Okay. Plus, let's look at this 5 times the square root of 50. So the 50, how can we break that down? 25 and 2, 5 and 5. Looks like it'll work. I've got a pair of 5's. So a 5 can come out. So I've already got a 5 there, so it's going to be 5 times 5, that's the 5 that comes out, times the square root of, I've got that 2 left over. So I believe that works out to 25 root 2. And then lastly, minus, I've got this 32 to deal with. How can I break up 32? I could go 16 times 2, and then 16 is 4 times 4. Now, I could break up the 4's more into 2 times 2 and 2 times 2, but I'm not going to because I have a pair of numbers. I've got 2 4's. So a pair of 4's means a 4 comes out of this radical. So if a 4 comes out, that's going to be 7 times 4 times the square root of, look at that, I've got a 2 left over again. 7 times 4 is 28, so it's going to be minus 28 root 2. So you'll notice after simplification that all of them have root 2, and they all have the same index. So what that means is I can now add and subtract everything. I've got 9 plus 25 is 34, and 34 minus 28 is 6. So all of this becomes 6 root 2's. I have 9 root 2's, I'm adding 25 root 2's more on, and then I'm taking away 28 of the root 2's, which leaves me with 6 root 2. So another example of addition and subtraction of radicals we want to look at here, but notice that it involves third roots. That shouldn't be too much more difficult to work with because what's the rule? I can add and subtract radicals as long as they have the same index, and since they're both third roots, they do, and the same radicand. In this case, 24 and 54, they're not the same. So we need to simplify. Let's look at that 24 first. Now be careful here because we're dealing with a third root, which means I don't need to find pairings of numbers, I need to find triplets of numbers. Let's see, 24 could break down into 12 times 2. 12 could break down into 3 times 4. The 4 could break down into 2 times 2. So you'll notice here that I've got a 2, 2, 2. I have 3 2's. And then I've got this 3 right here left over. So because I have the triplet of 2's underneath a third root, a 2 can come out. So that's 5 times 2 times the third root of, what's the number left over? The 3. So 5 times 2 is 10, so it's 10 times the third root of 3. Minus, let's deal with this 54. Let's see, 54 I believe is 2 and 27. 27 is 9 times 3. 9 is 3 times 3. Okay, so notice again, I have a triplet of 3's and a 2 left over. I have a triplet of 3's and a 2 left over. Okay? So as I simplify this, I know since I have a triplet of 3's, a 3 will come out. So that's 6 times 3, which is 18, but then it's times the third root of, what's the piece I have left over? It's a 2. So it's minus 18 times the third root of 2. So now that I've simplified, you might say, go ahead and just do the subtraction now. 10 minus 18, is negative 8 times the third root of, here's where the problem is, the third root of what? In order to add or subtract, what was the rule? I have to have the same index, which I do, they're both third roots, but I have to have the same radicand. And in this case, I don't. So really, this right here is as much as I can simplify. I cannot simplify anything beyond this point because they don't have the same radicand. So I cannot actually perform the subtraction. I simplified by getting as much out of the radical as possible, but I can't do anything else because I don't have the same radicand. Last example we want to look at in this lesson is the case of having two radicals that we're multiplying together. So in this example we have 5 times the square root of 4x to the 5th h to the 4th times 3 times the square root of 16 x to the 4th h to the 3rd. There's one simple thing we can do that puts it in a context that we've already done. If you have two radicals being multiplied together and both radicals have the same index, in this case they are both squares, what I can do is I can just right off the bat combine them, combining like parts. 5 times 3 is 15 times the square root of, since the 4 and the 16 are both under the square root, I can multiply them together and keep it under the square root. 4 times 16 is 64. I then have x to the 5th times x to the 4th. When I multiply x times x, I add exponents, so that's x to the 9th. And then I have h to the 4th, h to the 3rd. That becomes h to the 7th. So what this has done now is it's put it in a context that I already know. So all I have to do is finish simplifying this, getting as much out from underneath the radical as possible. So let's deal with the 64 first. Here's what I notice. I can automatically break this up into 8 times 8, which is a pair of numbers. Square root of 64 is 8. So 8 times 8 makes sense. So what does that mean? I can take an 8 and bring it out. So I have 15 times 8, that comes from the 64. Now I have x to the 9th. Remember, it's a square root. How many times does 2 go into 9? Or in other words, how many pairings can I get out of x to the 9th? 2 goes into 9 4 times. So that's x to the 4th. It goes into it 4 times with 1 left over. So we have to remember that underneath our radical, we're still going to have an x. What about the h? How many times is 2 going to h, or rather, h to the 7th, or rather, how many pairings can I get out of h to the 7th? The answer is 3. So I can get h to the 3rd because 2 goes into 7 3 times. 2 times 3 is that 6, but that leaves 1 left over. So I still have an h left underneath my radical. Finishing up the simplification, 15 times 8 is 120. So this becomes 120 x to the 4th, h to the 3rd times the square root of xh. So again, the key in these problems is to simply combine the two radicals together right off the bat. And then it's put in a context that you know already and you can simplify.